Sorry, I'm stressed out, but okay. Alright.
Alright, so what's more? So let's get to today's. I hope you can see my screen, but I'm not sure.
No, you're not sharing. I guess you say you're moving to Flutter.
Nah, yeah, let's two things then, probably.
Oh, okay.
Let me see.
Yeah, I can see your screen.
Okay. So today we are moving to polymorphism.
Hey, that one too is what?
Is it?
That one too is what?
We even did it yesterday, but I didn't mention it that we are doing it. It also, you see, the thing is linked together.
Oh, okay.
So don't worry, it's nothing. We've done it. We did it yesterday. So just brush over it. So polymorphism is simply let me get the definition. Making a function work. How should I say it? Different way. Okay.
Yeah.
So polymorphism is from the inheritance. We understand that from the inheritance aspect, we get access to properties from the mother class. Okay, so now after we've gotten access to the mother properties of the mother class, we can now override methods within the mother class. So that's what I'm saying. We did it yesterday. So there was an existing method within the mother class which was eat.
Yeah.
Okay. So this eat here, for instance, the animal is eaten. Now, with polymorphism, this is what we have here. So with polymorphism, we override the function of the method within the mother class. You get it?
Can you come again?
Okay, so I mean with polymorphism, we have this mother class here from inheritance. We are inheriting the properties of the mother class by inheritance, extending it, right?
Yeah.
So we understand that when we inherited, we got access to a method within the mother class, which is eat.
Yeah.
Okay. So with polymorphism, after we've gotten access to the properties by inheritance, polymorphism gives us the access to update or work differently with the existing method, which is eat. I don't know if you're getting what I'm saying.
It gives you access to.
Okay, let me read this one. It says polymorphism allows. Is the music louder than my voice?
No, it's not.
Okay. Polymorphism allows a subclass to provide a different implementation of a method. Polymorphism allows a subclass, in this case the dog class.
Yeah.
Let me bring it to this place.
you recorded the class?
Yeah. So polymorphism. Okay. You see, it allows a subclass to provide a different implementation of a method. So we are having two different keywords here: a subclass and a method. We also have three different implementations. Okay. So let me add hashtag to these ones. We have this one. And we have a method. Okay. So these are the three things you are looking at: a subclass, different implementation, and a method. So let's look at the subclass. The subclass is the dog here, which is inheriting the animal class. You get that one? Okay. Then let's look for a method. The method we are looking at is the super method, or the method from the super class, the mother class, which is this one.
Yeah.
Now it is pointing the animal is eating. Then with polymorphism, it is saying we can provide different implementation. So now we can get access to this eat method and make it work differently as it is meant to be.
Oh, okay.
So when you come here inside the subclass, we call the method by overriding it. So overriding is just as the word goes, overriding something, the actual function, you are overriding it. I don't know if I get it. I don't know if I can get a different word. Do you understand what I'm saying?
Yeah, I get it. I get the override.
Yeah. So we override the existing functionality of that class. Then what happens? We then provide print the dog eats. We can see it is different from what we have here. The animal is eating.
Yeah.
So we are providing different implementation.
So it's like you are cancelling out the first implementation and providing a different one.
Exactly.
Like a different solution. Yeah.
Yes. So yesterday I made mention that whenever we do override, you will see super dots, then the method name.
Yeah.
I explained that, but let me go over again. What it means is that this super dot is calling the mother method. Okay.
Yeah.
The actual method from the mother class. So what it does is it will execute whatever it is inside the mother method. Then it will add your new implementation to it.
Yeah, and I remember you mentioned that so without the super dot, it's not going to show the old
Exactly.
implementation.
Exactly. Without the super dot you will not get the functionality of this method executed inside for this particular subclass.
The mother class, yeah.
I hope that is clear.
Yes.
So this this is polymorphism. So we did it yesterday.
Oh, okay.
So that is all what polymorphism is about.
So just the overriding and then bringing a new implementation or a new solution to the whole thing is polymorphism.
That is polymorphism.
Oh, okay.
Do you have any question on that?
So, in what cases would you require, like, let's say, what use case would require you to use polymorphism?
Okay, so let's have a similar example. Since we'll be using Flutter, but okay, hold on. Let me use it. Let me try and get a real life example. Struggle. Let me think for 1 minute. Okay, so let's use this one. Naming in real life. Okay. So
Okay.
let's say you bear your mother's name or father's name, right? I don't know. You're a girl, right?
Oh, I'm an Ewe, but I can't speak.
Okay, so you bear your father's name. So
Yeah.
assuming you're a lady, you get married and you can now add your husband's name to it. Okay.
Yeah.
So
That's
adding your
true. That's
husband's
true.
name to it, you are changing your surname from your
Yeah. So you're
father's
overriding
name to
the first implementation,
and at the
which is
same
your
time you can maintain your father's name and add your husband's name as well.
husband's name. Okay. Okay.
So
Okay.
you
So
have
that's
a
when you
middle
have the
name and a
super.
surname.
Yeah.
I hope you get that one.
Yeah. So when you want both of them, you add the super. You leave the super. But if you don't
You
want
leave it.
the first one, you remove
Exactly.
the super. Yeah, okay.
I hope that is clear.
Yeah, that's cool.
Alright. So that is it for polymorphism. Let's get to abstraction. I think we did a pointing, so let me run it again. Yeah, so the animal is eating its first. Let me try and bring it second and see what happens. We know that it runs from top to down, right? So in this case, you're having the animal is eating, then the dog will eat. Let's see which one comes first. So in this case, you're having the dog will eat coming first before the method. This one is run. So it runs from top to down. So that's the reason. Okay, so let's get to abstraction. Okay. So for abstraction, it allows defining an interface without specifying the full implementation. Okay, so let me try and get the definition for the interface. Okay, so an interface is a structure that defines a set of methods that a class must implement. Interfaces are used to connect applications and software systems and to allow data and functions to be transmitted between them. So the basic definition is interface defines a set of methods that a class must implement. So let's use example 2. So for abstraction, it goes with the keywords abstract and a class. So abstraction is also a class, right? So we call it an abstract class.
Oh, okay. So that's like a keyword.
Yes. So this is an abstract class. So we say that this vehicle is an abstract class. So abstract class because we are defining methods within it that a class will need to implement them, right? So the class here will not have full implementation. You can have implementation though, but it will not be full. I hope you understand the implementation.
As in, like you won't use it fully or something.
Yeah, like the functionality of a method defined here wouldn't be fully executed. Like you wouldn't have the full functionality of the method.
Oh,
You
okay.
have the full functionality after it is being used by another class. Okay, so let me
Okay.
some of the things there for the beginning to be some. So we are going to say vehicle. We have void stats. Okay. So this is an abstract class with an abstract method. So abstract method without implementation. So you see, it's just like a method. We can add this one to it. Okay, this is a method, right?
Oh, okay. Yeah.
But we don't have add any implementation to it. Inside the body, we don't want to do anything right at the moment. We want it to be there for any class. We can inherit abstract class, right? So any class that will inherit this abstract class should then provide access to provide, what should I say, functionality to this stats. Okay. I don't know if you are getting what I'm saying.
Come again.
Okay,
One
so
last time.
this is a class, right? But it is
Yeah.
abstract, and the abstract will mean we are defining an interface. So interface, how should I say, like something we'll be using later, right? Something we'll be using later. So I've defined this method here. Start vehicle. We know vehicles has to start, right?
Yeah.
So I don't want this is a general vehicle. We have cars in it. We have motors and other stuff. So we know that vehicles generally has to start. So now we are providing a method to start, but it depends on how every vehicle would want to start.
Yeah.
So now when you extend the vehicle, then you provide your own implementation to start the vehicle. So we will then
Okay.
remove this implementation from there. Do you get what I'm saying?
So meaning that this method, you're not going to give it any instructions or what exactly to do, or you're
Yeah.
not going to add any bodies to
Yeah, we
it.
are not
But
adding any instruction.
anytime you call it anywhere, that's when you input those things.
Yes, you give the instructions to it.
Okay.
Let's proceed. Maybe you understand from the second. So this is just put the inheritance also in mind, because we are come to use the inheritance here. So we are now come to create a class car, okay, which inherits from. Do I have a class car already? Oh, okay. So let me use bike, okay, which extends vehicle, which is inheritance, right? Okay. So this is vehicle. Bike is extending vehicle, which is inheritance happening here. Now we have to implement polymorphism, right? We have to override the functionalities, but bear in mind this doesn't have any functionalities at the moment. We can still provide functionalities though if we want. Okay, so the moment we provide functionality, you see the error here is gone. Okay, this is a method doing nothing. So doing nothing is the function of this one, right? But when the moment we make it abstract, then it requires whoever overrides it to provide implementation to that. So to provide implementation, we're going to call the name stats, which comes with override, which is polymorphism. We now have to provide our functionality or implementation to that. So I'm going to say print by stats now. Okay. That isn't making sense. We have the mother class here. Okay. So this is a vehicle, general broad vehicle. We now come to bike as part of the vehicle, motorbike as part of the vehicles. Then it is extending vehicle because motorbike is also a vehicle. Then we know that the vehicles must start. So we are overriding the start. They provided us with the start method without any way of starting it. So now the motorbike picked that functionality or that property. Then it'd be like, oh, I will start my machine this way.
Okay.
So
you are now providing the implementation for it.
Exactly, I'm now providing implementation to it. So now we come to the main. Let's print what we have there. So we have car. Sorry, I use bike. Okay. So we can say bike dot start, right?
Yeah.
Okay, so if I should run this, we're getting bike start now. I don't know if you are getting what you're doing now.
Yeah, I do. So it's like, so the abstraction is like, you, even though you key in a method, you don't really provide any implementation to it, or even if you provide, it's not the full thing. And then you now call that particular method when you are doing the, what's the name, polymorphism, and then you override that one, and then you key in the actual implementation that you want, the full implementation that you want.
Exactly. That is all.
Okay.
So we are done with the object oriented.
So what did you case for this one as well?
Okay, so this is mostly used. No, I don't say mostly used. From what I've been using so far, I mostly use it in clean applications, where I have to define some methods and implement them later. Okay, and you can also use it in scenarios where, let's say, you have a broad functionality. Okay, a broad functionality, but as we've done right now, it is a mother class that other classes will be inheriting from. You don't have to. You don't want to provide functionalities which will be general. You want to make the functionalities like specific to a particular class. Okay, so you generalize that and just make an overriding to each of them, so that you have a centralized concept. So you just right now you need a basic understanding. So when time gets to you understand it better.
Okay,
I don't know if the scenario I gave was okay.
Yeah, now I get a basic understanding. So I think we can move on. When you get to actually use it, I'll get it.
Yeah. And we might even not use it in our tutorial session.
Oh, okay.
Yeah, I'm not sure. We will not get to that extent using abstract.
Yeah.
Okay, that is fine now. So we are done with the object-oriented programming, the four main concepts. That is encapsulation, inheritance, polymorphism, and abstraction. So the encapsulation is basically creating, making private methods or properties of a class private. Okay. Inheritance is extending hands to maybe a mother class to access properties of that particular class. Polymorphism is you being able to override the ability of a particular method within a mother class. And abstraction is creating an interface without specifying implementation or full implementation. Then you implement them, or you fully implement them after it is being inherited through polymorphism, that is overriding. So that brings us to the end of object-oriented program. Any questions so far?
No questions.
It's quite plenty. Unless you go, maybe you might have to go over to get it clear.
Yeah.
And some of them too, you'll be using them often. So it might not be, the definitions might not be off head, but for the
Yeah, I'll get
practice,
to
you
once I
know it.
understand the basics of it.
Yeah.
I think I'll be good to go. Yeah. Go ask for the inheritance and all that. The one they
Well,
understand.
I started programming long time and I didn't know about it. Knew I was using it.
Oh, okay.
So it was, I think it was when I was about to make a video of it. Then I had to really sit down and look into it.
Oh, okay.
But meanwhile, I was using it. Yeah. But to get the right terms to teach, I had to go over it.
You didn't know the right terms, but you knew the concepts.
Yeah. So that is it. So from here you have to move to Flutter. Let me pause the video.